Snowflake. I'm part of Snowflake Professional Services based in EMEA. So I'm based out of London. My SI partner, Prakash Desai, was supposed to be here from ITC Food. Unfortunately, he had issues with his visa appointment, I think which a lot of you probably can relate to, because of which he couldn't be here, which means you will have to bear with me for the next 20 minutes. So what's a challenge? This is something which you all relate to. We live in an information era where organizations are ingesting data from multitude of disparate data sources, from your on-premise relational databases, flat files, third-party files, talking about weather data, foreign exchange. We're probably also ingesting data from IoT and industrial IoT, data from machinery, automobile, medical devices, and so on. Added to that complexity, you have different types of files. You have structured files, you have semi-structured, you have unstructured. How can you actually go about ingesting all these files to basically load into, say, Snowflake, and then start defining your transformations and derive insights and value out of your information? How can you actually build something where sort of the ecosystem looks a bit more complicated? So this was a problem statement that we had, and we already have quite a few data availability services out there in terms of data as a service applications, where you have modernized ELT tools providing support for not just your on-premise, but you also have support for a lot of cloud-native applications like Salesforce, Workday, and so on, which is pretty good in terms of extracting the data, loading the data, and then doing transformations in terms of push-down SQLs and optimizations. And there are a few tools out there which sort of provides you sort of a self-service capabilities, where you can probably have the ability to ingest data in minutes, so that your data availability is pretty much real time. So you can derive meaningful insights and information off it. And they offer you resiliency in terms of business continuity and scalability in terms of having the ability to provide that unlimited scale, so that you can sort of run your multitude of workloads in parallel without any resource contention. However, there is a problem, right? And the problem is the fact that in terms of building your data pipelines, sometimes, more often, you might over-engineer a solution. And this is what we refer to as a therapeutic effect. And also, you have a lack of cohesion, because all these applications in terms of defining your data stack are tightly coupled. What that would mean is if there's an issue in one, it would impact the other. And that's what's prone failures. So the more hops you have in terms of your data pipeline, you're sort of building a more complex IT estate, right? And what we thought about resiliency and efficiency may not always be the case. So how do we go about reducing the delays? How do we go about reducing the complexity? So that's what, here's the thought process to it, where we had a problem statement in terms of understanding when Snowflake as a platform provides you all the capabilities. What is it we can actually do in terms of building a framework which is configurable, but also provides better control of your data, help you make better data decisions, and optimize your data availability strategies. Thinking about it, that's the term actually came up with at a customer side, saying when you actually made investment into Snowflake, why wouldn't you want to sweat the asset? Why don't you want to maximize what you have in Snowflake? And I'm pretty sure you all been through the keynotes, and you really understood what sort of capabilities Snowflake offer, from ingestion all the way to consumption and beyond, right? In support of native apps and so on. There is so much potential that you can actually build in terms of leveraging the Snowflake capabilities. And this is what we tried, and this is what we built. We call this the no-code ELT framework. I call it no-code, but you have to probably take that with a pinch of salt, because there's still an element of coding, because you still have to write SQL transformations to match your business logic and so on. But what we sort of built is a framework which helps you a lot of use cases that we're going to talk about. How do we go about building this, and what are the key success factors in terms of your framework? As with everything, when you want to build something, you need to have measurable insights to actually give you the confidence that it sort of ticks all the boxes. right? And these are the key things that we were really looking for. How can we actually build something which is very native in Snowflake that helps you with a faster migration of any complexity, data volumes, and so on? And why stop there? Why can't we actually have the same framework which helps you manage your daily pipelines as part of your business as usual processing? That really makes data availability in real time. And how about we actually extend the functionality to provide you what we call the data observability, which is the new buzzword, where you have a complete control and visibility in terms of what the cost is, what the bottlenecks are, which helps you really understand and identify what the pain points could be, and how do you go about eliminating waste. What I mean by waste is, how do you minimize the delays and increase the efficiencies so you're actually making decisions based on the data or not based on gut feeling, right? We all talk about data democratization, but I think there are very few companies out there which has actually realized data democratization, and that can only be realized where you have the likes of the CEO all the way to a data analyst using data to make decisions. And that's one of the key objectives that we really wanted to achieve using this framework. So what does it look like? This is what it looks like. This is the solution blueprint of what an ELT framework looks with Snowflake native capabilities. What you see in the middle, what's referred to as the framework quadrants, is basically the data fabric. And these are some of the native functions that you all can relate to. On the left-hand side, you have the external data sources, which is residing on any of your cloud storage. It could be Azure Blob, S3, or GCS. And you're ingesting data using native SQL capabilities, like it could be your copy statements, it could be external functions, it could be stored procedures. It has also the support for Snowpark in future. But what you're seeing here is just using Snowflake functionality to build a framework. And it's not just a framework in terms of making data available in the target, you're also leveraging Snowflake capabilities in terms of accessing information schema, accessing account usage. So you can extend to actually build a monitoring dashboard, which is what we refer to as the command center. That talks about the FinOps, the data ops, and the usage stats. So you have complete visibility of what your product ecosystem looks like. So we talked about the design for data pipeline, but this is another thing which you all can relate. Most of the organizations are multinational, where you have presence across several countries in the globe. How can you actually build something where you have visibility of all the jobs executed across different countries? Like, how do I get visibility of jobs, say, running in India against jobs running in UK, against jobs running in Tokyo, and I want all the information pretty much in real time? We've seen how air traffic control operates, where it sort of manages all the flights. So what we sort of brainstormed is, why don't we actually build something very similar to that, where you have visibility of each and every element of the command center. Again, talking about not just the cost itself, but focus on data quality issues, focus on reconciliation, focus on compute, focus on usage statistics. So why don't we actually build a dashboard and make it visible, make it available in real time, so anyone in the organization can actually see live status of your jobs and basically understand what information he or she can absorb. And this is what the whole control center looks like. Again, it's all built using native Snowflake. In terms of the actual user interface, what we've done is we've actually built a framework using AngularJS, and that's just the UI in front of it, where you just fill in the metadata of what you want to ingest. And once you fill in the metadata and press play, everything is automatically generated in the backend. So all your SQL statements for DDLs, all the SQL statements for DML, SQL statements for creating tasks in terms of defining your scheduler, the sequence of the schedule, everything is automatically generated. All the SQL code is automatically pushed into any form of CI/CD. Currently, what it supports is Azure DevOps, but we're sort of looking into supporting other CI/CD tools out there. And everything is version controlled, everything is managed automatically for you, and then deployed based on the various peripherals and that we sort of defined, which we'll talk about. So what was the actual case study in terms of building this framework and how did this case study actually, how was this case study implemented, leveraging the framework that we actually built. So we worked at a customer which is a famous FMCG group. What we actually worked with is one of a key business unit within the customer, where they had a marketing business unit, and they used to analyze all the call logs, they used to analyze the campaign management, the survey management, and it was pretty crucial in terms of leveraging the brand of the organization. And the issue they had is they supplied data to a lot of third-party markets, and there were about 33 different markets that they were sharing data to, and it was sort of bidirectional. So the customer would share data with the end market would then enrich the data and publish the data back to the business unit. However, as the company was planning to expand beyond the 33 markets, they really couldn't scale any further. And even within 33 markets, they really had issues in terms of optimizing and leveraging additional new use cases. And the main problem is that it was so tightly coupled that the only option they had was to re-architect the entire platform by sort of segregating the distribution of your compute and storage. So the only option we had is to sort of look at how framework would actually help this implementation. Right? So the starting situation with the customer, they had 2,000 plus KPIs. The data volumes weren't huge, it's just about 20 terabytes. But the problem is the number of data components and data pipelines that they had in the ecosystem. They had 33 different markets, and each of the market was in a different country. So you can represent the 33 different markets as 33 different countries who were actually accessing the data. And they had lots of global dashboards. Each of the dashboard was independently managed by business users within those end markets. So to sort of summarize the challenges in ecosystem, the number of cloud components sort of breached all the architectural guardrails because there wasn't really a consistent way of defining and managing these cloud components. They had different versions of solution scripts for transformation and data management. I did the MRA, which is the Migration Readiness Assessment. It's one of the professional services offering, which really helps you understand what's the cost of the migration, how long will it take, and what would the migration look like, and so on. When I did the Migration Readiness Assessment, we estimated this to be around 9 to 10 months migration. And the customer came back to us saying, we can't have a 9 months migration because they were approaching a SOC 2 business freeze, which means that the migration had to happen like in 6 months' time. And that sort of helped us brainstorm the idea of building this framework so we could accelerate the whole migration. And the other key challenge that the customer had was the growing run cost, because there were too many technologies as part of the data pipeline, so they really couldn't optimize the consumption. So given these challenges, this is a solution blueprint that we actually came up with, not just managing the migration itself, but in terms of defining the whole data framework. That's the whole journey of any of your data pipeline, where you have your data being ingested, and that if you're actually doing a migration, then you would look at your code migration, you would look at your data migration. But once your migration is complete, how would you then go about onboarding your new data sources? And how do you go about managing your resources dynamically, right? Snowflake provides you capabilities to address all these components within your ecosystem. You have the info schema, which would really help you automate, understand the definition of your table structures from the file. You can build an automated legacy code converter. So if you have like your high DMLs or high DDLs, you can easily convert that into Snowflake compatible DDLs, the table definitions. You can sort of build a data migration toolkit which would really help you not just migrate the data, but help you with the reconciliations. A key other emphasis was data quality. How would you go about automating your technical data quality? And if you have to enrich that for your business use cases, how would you go about doing it? Most of you have actually been using the likes of Great Expectations, and there are quite a few other open data quality libraries out there. So how do you sort of embed all those best practices and standards and sort of build a data quality framework where you can easily integrate that with your platform seamlessly? Again, all using SQL statements. How would you then build your ingestion pipeline, right? That could be for your batch processing, that could be for your real-time processing, that could be for your micro batch processing. You have the likes of Snowpipe, you have the likes of Copy, that really helps you segregate based on your workloads. And how do you build a command center to manage your data observability? So what we actually did is we split this whole ecosystem into individual components, and we sort of tackled each of those components and stitched all those components together. And again, everything was just SQL statements. And once we had those SQL statements, what we had to do is sort of wrap everything into a framework that can be dynamically generated. So all the user has to do is provide the metadata, provide the execution sequence, and provide the transformation location as well. Once all the metadata information is provided to the user, what you see here is all automatically generated, deployed from your dev, unit tested, and then promoted to higher environments. The benefits that the customer actually had by using this framework, first was the speed. Like I said, we estimated the migrations to take 10 months. However, all the 33 end markets, which is data migrated off to 33 different countries, was onboarded in 24 weeks. What that meant is there was at least 50% reduction in the pipeline and cost, which was really significant for the customer. So much so that the customer were actually planning to go live with an additional 3 markets this year, but this gave them an opportunity to onboard all additional new markets last year. So that was the key advantage that the customer had, where using this framework, you can accelerate your onboarding process. Next is the performance. Using this framework, it actually obtained 33 times faster ETL processes. And the reason for that is because you sort of simplified your architecture. You sort of built a seamless architecture using Snowflake capabilities, which means that leveraging dynamic compute, which supports parallel executions and so on, your data is now available in the target system as it's available in the source system. It may not be real time based on the complexity of transformation, but at least it was a lot better than what the customer had previously. In terms of the cost, there was a significant reduction in run cost through data simplification. So you not just simplified your architecture, there was a significant reduction in the number of performance issues as well, and also the number of failures that the customer had. In fact, in this project, customer had absolutely 0 failures when it came to Snowflake related. There were quite a few issues on the data side, on the source, but not the target side. So using this framework, the customer was able to achieve migration in record time. And in terms of collaboration, by having the best of breed capabilities from Snowflake as a product and Snowflake as a professional services, and I'm not sure if anyone from ITC Infotech is here, but using a great SI, we were able to build a more accelerated framework that not just accelerates your migration, it can accelerate your digital transformation and ensures that you're mobilizing your data from day one. And that was a key message where we didn't have to adopt any additional technology. You could build a framework just using Snowflake capabilities and leverage that to fulfill your business requirements. I don't have time for the demo, but if you're really interested, please leave a feedback. This would really help me understand the content, understand the presentation, and if you're really interested in some form of a webinar, I'm more than happy to do that.